Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. So today, as agreed, I am making the recordings, okay, for the FYP GIS short course. Now, I would like to divide this entire video into several sections. First of all, we will start with the download of the quantum GIS software, where to look at, and then followed with the preparation of the data, and then only then we can start with the analysis. So to start with, simply type quantum GIS download for Windows here, like this one. Okay. Here you will be given the latest version of quantum GIS. If you want to donate, highly recommended. If you do not, you can simply skip and go to download. So there are two types of software being given here, two version. Do not click the latest release because this is experimental. Please download the long-term release here. Okay, so you may click the download button and then wait for the download to finish. But of course, I have already downloaded just to cut short the time. So I go to the download section, my download folder, then I double click it to start the download process. All you need to do is to click next and then accept the license agreement, next again. Create the desktop shortcuts and also the start menu shortcuts. Why not? Click next and click install. As simple as that. So while waiting for the installation to complete, I want to show to you the data. So the data that I will provide to you is like this. It comprises of actually three. Here, I delete it. Comprises of three files. Okay, if this one pop up, the open source geospatial foundation, simply click yes. Okay, so that it proceed with the installation. Now, there are three data that I will give you. First is a Google Earth map. It is an image from Google Earth of your study area. Next is a sampling location, the GNSS data over here. This data give you the latitude and longitude of the sampling point. Okay, so you can use Google Map in order to obtain this latitude and longitude. Let's take a look. Go to Google Map using your phone, of course. Okay, through your phone. When you go to the fieldwork, whenever you arrive at the location that you want to do the sampling for, let's say, water quality, right? So you need to obtain the data of the location, okay? Obtain the coordinates. So how? Here, no. So here, I'm showing to you through Chrome from my laptop, which is not, of course, you are not going to open your laptop at your working site. I'm going to show to you the developer tools over here. So let's say you are using iPhone 14 Pro Max. Okay, all you need to do is to click at the area that you want to have the coordinates, which is the area that you do the sampling lah. Okay, let's say you do the sampling over here. You click like so, and then the what we call this, the coordinate will appear. Okay, if you want to copy, I believe you hold this value long enough, it will copy the value. If it is not, you simply select this, and then it will appear over here or over here. Then you may copy the coordinates. But I just noticed here that the coordinates given is not in decimal degree. So you need to actually copy this one, the decimal degree. I believe if you click long enough, it will copy the value, right? Now, that is how you collect the GNSS data from your working sectors at your sampling points, right? So highly recommended also, whenever you locate the sampling points, you need to also describe the sampling point, whatever in the area. For example, here I'm taking the riverbank, and then I mention the riverbank at point one here is near residential and commercial drainage. Point number 2, close to jetty, okay, and so on. Okay, perhaps point number 8, close to another 40-meter fish farming, something like that, fish cage, something that will help you to explain why the results show like this and that. Okay, now this is the GNSS data. The second data that I provide to you is the lab data. The lab data is the one that you collected in the working sectors, in your working site, and then you do the lab analysis. So this is the data that you receive firsthand. Okay, now let's take a look at the installation. How is it? Still ongoing? Right. So the first steps that you need to do is to produce or to create your own working folder. Okay, now it's finished. So let's put that aside first. No, I don't want to save the raw data. Okay. If you receive anything, if you have the raw data, the first-hand data, I highly recommend you to what we call this, to make it as a backup file. Okay, so today is the 5th of May. Actually I did the video last night, late night, but I believe that, you know, that's not a good video. That's not a good video, but it's okay. Now, this is the raw data. Just now, what I did is I created my working folder. Okay. So whenever I have some analysis, some new data or anything, I will dump it over here. I will place it here. Okay. And this files working folder highly recommended to be placed in drive D, not in drive C. sometimes when we deal with large data, if you put it in drive C, let's say in your desktop here, it will reduce the performance of the GIS software usually. Okay, it depends on the size of the data that you are working on. Now, so first thing first, let's prepare the data. So how to prepare the data? We are going to combine this latitude and longitude together with the lab data. Okay, I simply right click and insert two new columns to put the latitude and longitude data here. As you can see also, the point is arranged accordingly, okay, from point 1 to point 12. Similarly, for the GNSS data, from 1 to point 12, like so. Okay, so I simply copy the latitude and longitude over here, and then I place it here, the latitude and longitude inside the lab data. Okay, and then I go to File, I export it. No, not export, save as inside the working folder. Okay, the new working folder, and I select the CSV data, comma delimited format. Okay, and here I write as prepared data, and then I click save. Some features in your workbook might be lost. Save CSV. Do you want to? Yes. Might be lost is it is not necessarily lost. Okay. Now next, the data has been prepared. I want to show to you on how do I make this and why. Okay. So you need to install Google Earth Desktop, Google Earth Pro Desktop. It is free. Okay, and then you zoom into your working site. Let's say here is my working site. Let's say, okay, over here, the entire image here will be my base map. There is another way in having the base map, but it is not recommended because the process is actually having the entire map of the world to be inserted uh, into your processing, okay, into the data frame of the quantum GIS. So depends on your internet connections. Usually it will slow your processing. So I highly recommend you to have your own base map. Either you collect it from the Google Earth, or you fly your own drone to collect the image of your study area. As for this case, I'm going to show to you on how to obtain from Google Earth. So now, there are two steps, and there are two types. First type is where you actually fly drone. If you fly a drone, you need to establish the control point at a permanent markings or a permanent structure which is not moving. So for example, the permanent markings is here. You can place the ground control point over here so that you can trace the coordinates of this particular position. Okay, for the size of this area, if you want to fly drones, usually it will take around 6 to 8 ground control points. But here I just show you the data that will be collected from Google Earth. Therefore, I do not need 6 to 8 ground control points. Instead, I just need 4. So what I will do here is I go to the add place mark over here, click OK, and then I select the best place mark. Well, the best one is the one that I showed to you over here, or the other two. If you want to choose the other two, also recommended, but do not choose the rest. Okay, because the rest here, we do not know where is the exact place of the markings. Okay, sometimes if you choose thumbtack over here, uh, it can be at the tip of this thumbtack, it can be at the center of the thumbtack. We do not know. Like this one, whether the markings at the tip of this place mark or at the center of this circle over here, we do not know. But if you choose the target like this, definitely the center is the point that we will have the coordinate value. Okay, and then choose the best color. Well, through my experience, the best color would be red, because it is not as, you know, I show it to you. If you choose yellow, yellow is, give you high contrast, should be, but here it doesn't. Okay, here it does not. It dim the yellow color. So that's why I choose red color instead. So I choose red color, and then for the name of this place mark, I will simply copy the decimal degree from the latitude and longitude given. I separate it with comma, and I establish 4 points that is placed at the corner. Okay, I having some struggle to select. Okay. Oh, sorry. Go to properties, and then only then you can move. I'm so sorry. Okay, go to properties first, and then you move the point to the place that you want. Okay, that will be the first, and then I click have for another 3 markings. As for the Google Earth here, the data from Google Earth, you only need around 4 to 6 ground control point. It depends on the size. I'm sorry. It depends on the size of the area. If the size is very big, then you need to have multiple, perhaps additional of 2 or 4 ground control points. This is to cater the curvature of the Earth. If you go like this, highly recommend you to have 2 over here, 2 over here, and the total of 8. Okay, because we want the if you extend like this, the area will affected by the curvature of the Earth. But if you zoom in like this is a quite small study area, so it is good enough to have only 4 ground control points. Now I select everything, I mean the coordinates, and then I move the coordinates to one corner, and the last one will be at the bottom right. So with that, I have the four corners of this image. Okay. The purpose of this is to conduct the georeferencing or geocoding. Sorry. Wait. Okay. Right. So now we already have 4 points. Next, I want to show to you on how to capture this image. Go to functions over here, the menu. Yeah, this one, save image. Go to save image, and then by default, usually it will have the title, legend, scale, and compass. Okay, here, and by default, it usually be like this, current resolution. Okay, but I do not want that information, so I remove it. Okay, and the resolution I increase to 4K or 8K, like so. And then I make sure that all the points, the place mark is inside the image, and then I click save image. And then I go to the working folder. Okay, yeah, this one. And training to this working folder, and then I simply click save, like so. Okay, right. So here I provide the actual area. This is how to produce the Google Earth base map. Okay, so done with that, the result is, of course, will be like this. Okay, this is an entirely different place from that one. Okay, now next is to open the newly installed Quantum GIS. I think over here. Okay, recently added. So I simply select it and paste it at the desktop for easy access. Double click it to open. This version is 3.44. Something that you need to know is that Quantum GIS is open source software. It actually updated the software quite frequently. Okay, it updates the version quite frequently, but internally it does not have so many changes. The interface are the same, but yeah. Now I will show to you. I will explain a little bit on the interface of Quantum GIS, starting from the main menu over here. This is a typical main menu for new template, to open a file, to save this project. This one is not to open file. This one is to open a project. The properties and the print layout to print the map, and then to edit, to do some basic editing, the undo and redo, to paste and copy, something like that. To view the map, to panning the map, zoom in and zoom out. I believe this one you you need to have mouse. Okay, you need to use mouse to do GIS processing. Okay. It has also statistical summary for your report if you want to do some statistics. It has decorations to include temporarily the scale bar, the grid, some image or north arrow, and so on. Okay, the toolbars over here, as you can see here, there are shortcuts to access some functions. Here is where it located, right? And then the layer. The layer is where the data that you are going to upload it into this software. Okay, so the data will be in the form of layers. There are shape files, so on. There, if also there are vector files if you want to add in vectors or raster for image. Okay, and so on. Over here, there are a lot of formats. What else? Settings to suit your comfort. Okay, you can change the style. You can custom the projections by default. You can have some keyboard shortcuts and so on. The plugins. The plugins here is the extra processing that people or experts contribute to Quantum GIS. So it will shorten the entire processing works. But you need to be very careful on this. You need to check and recheck whether the data given or the results given is correct. You need to have some accuracy assessment. Okay. And then for the vector, if you want to do the analysis, vector analysis, you can go to this menu. Okay. It gives you some basic analysis here. Okay. Even though it is basic, but it still gives you quite a lot of analysis. Then raster, similarly, raster analysis, a lot of raster analysis, but not limited to just this part. I will let you know the other part. Some database query and database managing, and then the web to search for extra data from the website. Usually it will be from the OpenStreetMap OSM here. Mesh calculators. This one is for the spectral analysis using remote sensing data. Okay, there are a lot of options here. This is from the satellite data. Let's say you obtain the satellite data from USGS website. Okay, the free and open source website to download hyperspectral or spectral remote sensing data. And then processing, there are toolbars over here. Okay, model design if you want to design on your own. This toolbox is here, located here. If happens to be you close it by accident, not intentionally, you close it and then you can open it back through here, processing and toolbox. It will appear back. And then help, if you want to have some ask a quick query on how to do this and that, go to help contents. Okay, if you want to donate, you can go for donation here. And if you want to know the versions, you can go to about the software over here. Okay, that will be the main menu. Here is a basic toolbar. The basic toolbar for save, open a project, new template, okay, zoom in, zoom out, anything that I have already explained over here. But this one is the shortcut. All right. And then we take a look at this content over here, the browser. The browser here is a shortcut for you to add new data. Simply click and drop into the layers here. But of course, you need to know what you are doing, which data that you are selecting. Okay, and then the layers is the display of the data. Yeah, if you want to display the data, you need to bring at higher list in the list. Okay, so that it will not be superimposed by the top data. I will show you very soon. This is part where it shows the recent projects. And then this is the part where you can custom your templates. This is the by default in coordinate reference system, CRS, of WGS 1984 over here. This WGS 1984 is the standard coordinate system used by Google Earth, Google Map, and many other web service satellite image. Okay, right. So let's click for this project templates. Okay, double click to open. So this is the empty data frame. And then when you insert the data later, you will have some images over here, of course, image of the data. And if you want to check again the coordinate reference system of this data, you can go to this bottom right over here. It shows you the EPSG 4326, 4326. If you hold it, it will show to you WGS 1984 there. Okay. Now, if you want to have some rotations, you can have some rotations here. For magnifying, you can simply scroll using your mouse. Okay, the scale and the coordinates. The coordinates means the cursor coordinates. Okay, now that is the basic of this quantum GIS interface. So the first step, highly recommend you is to save the project. Okay, save the project into your working folder. Okay, perhaps write it as no. Write it as water quality project, like so. Here I'm showing you the water quality project. It can be applied for flood. It can be applied for any propagation pollutions, air pollution, noise pollution. It's up to you. Okay, a lot more. If you want to study on the mapping of what we call this underground water, yeah, the same. Okay, now give names and save it into your working folder and save like so. Right, now we want to add the data. The first data that we are going to add is you go to layer. Okay, add layer and add raster layer. Okay, we want to do the georeferencing first. Georeferencing is where we want to stage the base map that we have been collected from the Google Earth into this software over here. So layer, add layer, and add raster layer, because the image that we obtain from the Google Earth is in the form of raster. Okay, here pixel means raster. So I selected this and open, and I simply click add, and it will be displayed like this. But something to know that this one is not in a correct position yet. It is not in a correct position yet. Okay, so we want to stitch this at the proper and at the exact place of this area. Okay, do not forget that. So you can go to plugin. We want to do the georeferencing process. Go to plugin, select the first option, which will bring you these windows. Okay, and type georeference. Okay, Of course, I already installed this at the previous version and it's still available here. Okay, means it doesn't change much. Yeah, here when you selected georeference extension here, you need to install. There is a button install over here. Okay, if it is outdated, it will give you update plugin, something like that. Okay, so now I already have it, so I simply close it. You need to install it first, and then we want to start with the georeferencing. Go to wait. Oh yeah, go to layer and then select georeferencer extension over here, and this windows will pop up. Okay, and then we want to georeference the Google Earth base map. So we select this, open raster, go to your working folder, open the Google Earth base map, and it will display like so. Now, now we can start with the stitching process. The stitching process, the button is this one, add GCP point, add ground control point uh, uh, symbol over here. Okay, so click this one, and then you can zoom in to the first ground control point, like so. Okay, click right in the center of the place mark, and then type the latitude and longitude. So for the x-axis, it is from left and right, left to right. You need to put it as longitude. Data 101.003737, and then for the up and down or the latitude is 4.014691, like so. And then do not forget to select this, okay, WGS UTM zone 47N over here. This one is the projected. It is not simply WGS 94. It is projected into UTM zone 47N, which is Malaysian coordinate projection, like this. Okay, it goes through Malaysia peninsula, just the peninsula. For Sabah and Sarawak is 48N. Okay, 48N over here. All right, and then click OK. That will be the first point, red dots over there, and then you do the same for the rest of the other 3 points. Click, and then insert the x value or the longitude 04 4.001908 47N. Click OK. I'm sorry, 101.02020208, and then 4.015 806 47N. Click OK. One more over here. One oh one 020941 4.003212. Okay, like so. Right, so if you take a look here, there are slight changes, only slight changes that is required for this image. Okay, and then you click here start georeferencing, or you can go to File, Start Georeferencing. Okay, so start georeferencing. Please set output file name. Yeah, transformation type. Okay, you can do like that. Just simply start georeferencing, or you can start with the transformation setting first. Okay, it's up to you. To cut short, simply start georeferencing, and then it will ask you the output name. Select this transformation type as linear, target coordinate reference system, the CRS, as WGS 1984 with projection of 47N. And then, okay, if you want to look for this inside here, you can simply type it like so. Either you type the here 32647 or UTM or 47N. 47N, for example. There are other type of 47N, but you need to choose this one, WGS 84 47N. There are hundreds, if I'm not mistaken, hundreds of coordinate reference system. So watch out. Okay, for Malaysia, this one. For other countries, you need to study what is the coordinate reference system that they are using. Okay, and then the output file name, make sure that you save into your working folders. The name is too long, so I rename it as GE projected. Okay, it will save in TIFF files, and this is the only format that is given, and save. Right, so the resampling method, nearest neighbor, you can choose others, but by default nearest neighbor is good enough. And then yes, click OK. Right, so has it started? And then run the georeferencing. Okay, just now is actually the transformation setting that we set over here. Okay, and then you need to run the georeferencing. One more thing, you can also save the GCP marks that you have insert the value. Go to file and then save GCP points, like so. Save GCP points. This one is optional. You want to have it or not, it's up to you. So Google Earth GCP S, then save. All right. So you can close this one, and now you have two options. Okay. If you take a look, okay, the position of this is actually different with the position of the projected. Okay, this is raw. The new the input where it doesn't stitch to any coordinate system, and here the projected is the one that is stitched to the projected system. So to look for the file, to look for the layers, you can simply right click this and then zoom to layers. Okay, right click the layer, zoom to layers, and now this is the stitch base map. This one is the correct one. Okay, if I turn on the actual Google Earth base map here and then I zoom out, let's take a look. Doesn't show it, missing. It is actually two different files. Okay, This one is the bigger one. Okay, but we are not using it anymore. Now, the best is to remove the layer. Just now you see that the back side of this projected layers is, it goes dark, you know, because the the raw uh, the raw image is actually bigger than this image. So okay, let's proceed. Now, what should we do next? After georeferencing, oh yeah, we will now go to the next part, which is to digitize the river. Okay, but you need to understand your working folders. I mean your working, you need to understand your working area. Okay, here I believe the image shows here is during um, not during the rainy season, or at least the water is shallow. Okay, the water is shallow. Um, that's why we can see the sand over here, sand river bank over here. Okay, um, it's supposed to be submerged. This sand over here is supposed to be submerged. If you look at this, the darker side here means it is very deep, and this one a little bit shallow, and this one even emerge from the water, from the river. Okay, so we are now going to digitize this area, okay, this river. What you need to do is go to layer, create layer, and new shapefile layer over here. Select this one, and then save into your working folder with what river, yes, river boundary, like so, and then click save. The geometry type, there are three at least, for vector, point, line, and polygon. So this river will be in a form of polygon. And then the coordinate reference system, here you need to select the projected coordinate system. Okay, we want to tally everything, so we select the same projection of coordinates throughout the entire project, and then you click OK, like so, and you will create a new empty and blank layer over here. Double click at the color box, go to symbology, change the colors to blue for water, something like that, and the opacity you reduce it to 80% perhaps, and click apply, OK, like so. Now this is the empty shapefile layer. We want to insert the data. Now we are going to digitize. We are going to digitize the river into a vector polygon shapefile. So simply right click, go to toggle editing, or if you have the toolbar over here, click this one, toggle editing. Okay, toggle editing, and then you need to select the add polygon features over here. Add polygon features. You the cursor will change, and then you can trace the riverbank. Trace the entire riverbank, like so. Okay. If you ask me, I will include the sandy riverbank, like so. And then once you finish, right click and then click OK. Simply click OK, like so. Now, this is the digitized riverbank. So before you do anything else, click Save and then close the editing. Okay. Now, this is the digitized river boundary over here. Now, what's next? Okay, next, we are going to insert the prepared data. Okay, so go to layer, add delimited text layer. Search for the files, the prepared data. This one is the CSV. Okay, or you can, filter the types of files to CSV and then click open. Make sure that the file format is CSV, and then also make sure that the coordinate reference system is UTM zone 47N, and then click add, like so. Now the sampling points has appeared in your working sectors sampling area. Okay, if you want to take a look at the data, you can go to the prepared data over there, click open attribute table. Now you can have a look at the entire lab data, which includes the latitude and longitude of the points. Okay. All right, now I believe we are ready for the spatial analysis. Go to interpolation over here at the processing toolbox. Go to the interpolation, select IDW interpolation. If you want to use kriging, you need to download the kriging plugins. Okay. Of course, this is the prepared data for the vector layer. Select this one, and then the interpolation attributes. You need to select the first one, perhaps the dissolved oxygen over here. Okay, and if you want to produce maps, you need to make sure that the comparison, if you want to compare and overlay, make sure that the comparisons and overlaying process is made with the same units. You need to compare with the same units over here. And not compare, overlay. Okay. If you overlay together with other units, let's say milligram, milligram is normal, milliliter over here for the E. coli. Okay, so it will distort the results of the data. It will not be accurate. Okay, so now let's choose dissolved oxygen, and then click plus over here and scroll down. The extent is where the spatial or the IDW algorithms will go to the entire image over here, or simply go by the river boundary, or just go by the sampling point. Now, my advice, you need to at least go by the river boundary. Okay, so that it will cover the entire river. Secondly, if you do not want to choose for the river boundary because you are doing flood, for example, for flood people, you need to choose the entire working sectors, the base map. Okay. Perhaps for air quality also. Air quality, noise pollution, you need to select the entire base map. But for water quality, it is limited to the river only. So choose at least the extent is river boundary. So I choose river boundary over here. Make sure that this one, the EPSD, is the projected. And then I change the pixel size to 5 decimal places. Okay, this one is 1 decimal places, 0.1. It's too big. So I add 0.0001. Okay, so that the rows and columns of this raster size is just good enough. If you want to make it more detailed, you can add more decimal. So, but it is good enough to have just 5 decimal places. And then the data you need to, if you didn't choose anything here, it will save as temporary file. And if you close this project and you open it back, it will be gone. So why not just simply save to file? Okay, remember that the file that you save is dissolved oxygen, and the processes is IDW analysis. So DO IDW, and then save, and then run. Okay, close. So it will look like this. Now the entire river is covered. I bring the river to the top, and then you can see the river is over here. Okay, but I want the interpolations only inside the river. I do not want it outside the river because my study is not included on the outside area over here. So what I can do is to go to GDAL over here inside the processing toolbox, and then I click raster extraction, and then click raster by mask layer. Click like so, and then the input layer will be the DO IDW, while the mask layer will be the river boundary, okay, the polygon. And then anything else is optional, do not worry. Let's take a look. Okay, nothing. I believe, and no, I should have, oops, sorry. Okay, I should have the functions to save here to save the file. So now click mask. I do not want it to save as temporary file. Instead, I go to save files. Now I put it as do idw clip. Do idw clip, and then I click save and run. Okay, now a new file emerged. So I will close this do idw, and I will also close the river boundary. Now you can see the interpolation of IDW just on the river side, but it is not, aesthetically pleasant to have just gray value, black and white. So let's change the colors. Right click at the layer, go to properties, and then go to symbology. For the render type here, single band gray, change it to single band pseudo color. Single band pseudo color, and then You can choose other color RAM. Let's say from red to blue, you choose, you can custom, of course. You can choose other from white to green. Spectra is the red to blue. Turbo from very dark to very dark color. But yeah, Spectra is to me the best to feel it here. Okay, now the level of precision is up to you. You can have to up to 4 decimal places or more. It's up to you, and you can have it up to what, 7 decimal places. But I believe only 2 or 1 is enough. Okay, let's say I choose 1 as a label, and then if you want to choose a different mode, let's say the equal interval. Remember from the theoretical lecture, you can choose equal interval, quantile. Okay, even you can classify on your own. Okay, you can add number of classes and so on. Okay, let's say I choose just by default continuous, and then I can change the layer rendering, the colors to make it more beautiful. For example, the contrast, I increase the contrast, saturation, and so on. I do not need that now. I simply click apply and OK. So this is the result. Okay, I can bring this prepared data on top so that people can look at it and have the idea where is the sampling point, or I can simply remove like so. Okay, now what else? If you want to do some, let's say we go for simple statistical summary or elevation profile. Let's say elevation profile over here. You want to look at the changes of the, here is DO, dissolved oxygen. You want to look at the changes of the oxygen level in the water. You can go to capture curve from features like this. Okay, simply make a line. No, first go to, sorry, go to vector, capture curve, this one, make a line. Okay, in the middle of the river, for example, and then right click. Okay, and then right click. Now select the capture curve from features button. Nothing yet. Why? Wait. It's supposed to have a graph over here, of course. Export results. Clear. Add layers. Where should I add layers? Oh, okay. Here, DO IDW clip, and then click OK. Now, actually, just now, it the elevation profile. Okay, the elevation profile does not has the data to extract and to show to us the curve. Okay, but now, yes, when I select DO IDW clip here, it shows the data. At the center of the river, the dissolved oxygen doesn't change that much. How about if I go to the extreme part at the riverbank? So I make another line over here, right click. There you go. Now it shows quite significant changes in terms of dissolved oxygen in milligram per liter. Okay, as it goes to from upstream to downstream, even though it is just few hundred meters or even a kilometer length, it has a significant differences in dissolved oxygen. Okay, if you want to explain further, you can go to properties here and then increase the transparency, okay, by reducing the opacity, perhaps to 80%, click apply, click OK. And then if you zoom in, you can explain, okay, the fish farm over here. How do I pan like this? I click the center scroll in the mouse, okay? Yeah, the blue here means high oxygen, high dissolved oxygens. So that means perhaps fish farm over here has high oxygen level compared to this one, or also got some fish farm perhaps over here have some problem, or the fish is not that healthy. Okay, but why now? Why is this area has low oxygen, dissolved oxygen? Perhaps you can take a look at the what we call this at the effluent, uh, the source of any river, small river here, okay, that is go into this main river. Perhaps, okay, you can do your own observations and analysis. Okay, so you can repeat the entire analysis. Sorry. Okay, now, uh, where was I? Where was I? Allah. Okay. Mm, here, if you want to explain further, I did mention if you want to explain further, am I? Museum. If you want to explain further, ayo, just now someone need to talk with me. You can take a look at this small river that goes into the large river, and you can have your own explanation. That was the last, am I? Yeah. Okay. I'm truly sorry. Forgot. If there is a other additional explanation that I want to talk, I forgot. Now let's proceed. Um, with the next steps. Oh yeah. Okay. Now I remember. If you want to do the interpolations, um, in bulk, as we can see, okay, you simply right click here, execute as batch process. If you execute as batch process, you can select several files and then you process entirely at one go over here. The um, the criteria or the characteristics that you need to fill in is about the same as you run a single process like this. Okay, right. Now, the next part is, please don't forget to save the project. Okay, so save, and then the next part will be on to produce the map. It depends. If you want to have only this one single map, then you can simply go to producing a map format. But if you want to display, just display in your paper, okay, um, you do not need um, you do not need to have all the characteristics of a map onto every maps that you want to do. Here the prepared data, okay, I showed you. You will have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you want to produce 12 maps, you do not need to produce these 12 map with the north arrow, the legend, the scale to everything. Okay, I correct myself. Except for the legend. Okay, legend you need to fill everything in. Here, I explain it if you still don't understand. Okay, let's go to new print layout. Print layout title. Here is dissolve dissolve oxygen. Okay, click OK. And then from here, I can insert the, wait, add picture, add 3D map, add map. Okay, add map over here. And then I select like so. Okay, now change the scale a little bit, make it bigger, like that. Now, what I mean just now is that you do not need to have north arrow at the at every maps, okay? Because the map is the same in orientations, the map is in the same dimensions, okay? So you do not need to have multiple arrow maps, but you need to have the legend, okay? The legend need to be inserted at every what we call this, every data that you display, every results of like this that you display. Okay, here we got some access data. We do not need to have river boundary. So you can remove. Yeah, how to remove this? Okay. Unselect the auto update. Okay, and then remove the river boundary. Remove the DOIDW. Okay, and leave only this one. Okay, even the GE projected also do not need to be included. Simple as like that. Okay, so this will be it should shows this prepared data over here. Please, you can explore. Okay, this one. Okay, you can explore what to add, what need to be removed. Okay, how the arrangement, but usually the legend will be on the right hand side, the arrow will be on the left hand side, but it depends on the data, depends on the river. If the river crossing from the top left to the bottom right, and then the north arrow will be on the top right, like so. Okay. There are another information that you need to include, perhaps the scale bar, okay, to show the size of your area, like so. Why meters? It should be kilometers. You can change the units over here, of course. Okay. As for now, I remove this one because I don't want to display it. To remove, you can go to here and select the scale bar. What's next? Yeah, if you want to add shapes, if you want to add image, add picture, perhaps you have the zoom out area of this area over here. Let's say I show to you based on our example here. Just now we focus only on this part, remember? Now let's say, okay, I show to you. I make a polygon. Let's say this is the first part that we show. And then you want to have some sense that people will know where actually this is located, this area was located. Okay, you can zoom out and then have another picture over here. Zoom out, perhaps have Penang, the entire Penang, and then the entire peninsula. You can have something like that, okay, to be included for this image. Add picture over here. You can add label, okay, perhaps the title over here. You can change dissolve oxygen, like so. And then font, change the font, you change the height. It is dissolve oxygen. You can change it, make it bigger, make it aesthetically pleasant for people to look at. Okay. If not, people just able to look at this legend over here. So that's all. The entire GIS practical that I want to show to you guys. Okay. If you want to add attribute here, you can add the attribute table. You can add the elevation profile. Perhaps you want to study, you want to show the center of the river, dissolve oxygen, okay, and so on. There are many other elements that you can include in the map. Okay, and then of course, how to close this? I forgot. No, history, and that will be it. Okay, that one is okay. Sorry. After that, you can export this entire project as an image. Okay, or you can export it as PDF. Sometimes you can just zoom in, okay, and then print screen this part only simply by click the window button shift S. Sorry, window button shift S, and then you select this area, then click save to, go to your working folder, training folder, and DO, IDW, final. So, yeah. And then you close this one to go back to the analysis part. Okay, with that, thank you so much for your attention. If you have anything that you would like to ask, please ask, because the more you ask, the more I learn actually. Okay. I hope later I will give you feedback, feedback form. Please fill it in. Okay. So with that, I thank you so much for your attention. Bye.